Hello my dear friends, my students. Today myself Dr. Rakhi Mishra, working as an associate professor in the Pharmacy Institute of NIET Greater Noida. So, today I am going to deliver a lecture on tetracycline part 1 I have already discussed, in which I have discussed about what are tetracyclines, what is their structure, what is their chemistry. Then I have also discussed about what is the classification, on what basis they can be classified. Then we have discussed that what is their mechanism. The very important thing which is remaining is structure activity relationship. It is slightly longer than the other compounds are, that is why I have prepared a separate lecture for it. So, in this lecture we will mainly discuss about the SAR of tetracycline by giving various examples. Okay. So, here we are starting directly. I have started with the SAR of tetracycline because in the previous lecture I have already discussed about tetracycline, but I will recall you something, that if we talk about tetracycline, then what are tetracyclines? They are antibiotics. The name itself denotes that they are having a 4 cyclic ring structure, okay, and the 4 cyclic ring structure is based on the what? Octahydronaphthacene skeleton also. We have seen that tetracycline mechanism is to inhibit the protein synthesis. How they are inhibiting the protein synthesis? By binding to 30S ribosomal subunit. By binding to 30S ribosomal subunit of what? Of ribosomes of bacteria, right. So, this is a glimpse of what we have discussed in the previous lecture. Okay. Again, a very important thing also is ki what is their classification. So, based on their duration, they can be classified as short acting, intermediate acting or long acting, and also based on their different you can say chemical structure, they can also be classified, or based on their sources ki natural, semi synthetic, synthetic, pro, right. Okay. Now, we are moving towards the structure activity relationship. See, I have told you that whatever we will study about tetracycline, we just have learned one main thing, that it is made up of 4 cyclic ring structure. So, here also are 4 cyclic ring. The rings are named as A, B, C, D, right. I have also told you that if we start numbering from here, then it is having O alternate, OH, double bond O and one OH, okay. This is present O, OH. Then in the second position we are having the CONH group, here it is also present. Then in the third position OH group is present, okay, and in this position NCH3 whole twice, that is dimethyl amino group is present. We have seen in our previous lecture that at least you should know, or at least the thing which are present in tetracyclines are these. What are these? 4 rings, alternate ketonic alcoholic group, then CONH2 group amide linkage, then OH group, and then very important dimethyl amino group. And now, what we have seen ki this area means this area along with CONH2 plane, they are occupied. They are occupied by what? They are occupied by ketonic and alcohol group, but these positions are remaining. No functional groups are here. So, these positions can be substituted by functional group, for example, R1, R2, R3 and R4. The same thing I have written in here. See, now see, 4 rings A, B, C, D, okay, and in both the 4 rings O, OH, O, OH, CONHR, OH, NCH3 whole twice is present. Now, what are the other because we here we are we have a discussion of structure activity relationship, right. So, in structure activity relationship we always see the effects of different substitution ki the place where we can do substitution, and what type of substitution is increasing the bioavailability, is increasing the activity, is increasing or is altering the other properties. So, here we can say that they can be substituted at these 4 places. What are those 4 places? R1, R2, R3, R4, and here also because it is CONH2. So, one hydrogen can also be replaced. And if we do the numbering, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have told you 5A, 11A, 6A, 10A. So, this is the numbering. Okay. Now, moving towards the structure activity relationship. What structure activity says? Ki keto-enol system, this is very important point. The first point you should keep in every answer. If they are asking about the SAR of tetracycline, then by closing your eyes you should keep this in your mind that either we talk about any type of tetracycline, keto-enol system, and keto-enol system is what? A system of double bond O and OH and interchange between, see here, if it is here then it becomes OH and it becomes O. So, in this way an exchange between O and OH, an exchange of electrons between O and OH, see here, this in this form, right, this in this form, the exchange of O and OH can take place. It is called keto-enol tautomerism. So, keto-enol system between the atom 1, this is your atom 1, this is your atom 3. Keto-enol system between the atom 1 and 3 is highly necessary for the activity. If we block this system, if we block this keto-enol tautomerism, then it will result in loss of activity. For example, if we put any substitution here OR, then this keto-enol tautomerism is inhibited, so activity will be lost. Okay. So, this is the first point, that keto-enol tautomerism is very important. Then at position 2 you are here seeing CONHR. At position 2 amide carbonyl group appears to be essential. Amide carbonyl means CO group. This CO group is essential, but this nitrogen you can replace. Okay. This is not essential. We are moving from A to other sides. So, from A and third we have seen the thing ki they are essential, and in the second position this amide CO group is essential, but nitrogen is not very essential. Again the structure is here. Various derivatization of amido group at position 2 give rise to derivatives which are freely water soluble in physiological pH and possess same activity as tetracycline. I have told you ki if we replace this R with something, then it will give rise to derivatives or either prodrugs which are very freely water soluble and they possess almost same activity when compared to tetracycline. The example is pipacycline. Treatment of tetracycline with pyrrolidine and formaldehyde gives another derivatives which is readily water soluble and which was also more active orally, that is Rolly-tetracycline. In the earlier lecture we have seen that Rolly-tetracycline comes in the pro-tetracycline, and this pro-tetracycline how it can be obtained? By the treatment of tetracycline with pyrrolidine. We have seen this type of ring is there with pyrrolidine and formaldehyde. It will give rise to readily water soluble derivatives which is called the Rolly-tetracycline. Next, clomocycline is said to attain increased blood level and have greater stability than parent chlor-tetracycline. See the structure of clomo and chlor, it is then clear to you. See, in both clomo and chlor, chlorine is present, CH3 is present, OH is present, right. NCH3 whole twice, NCH3 whole twice is present, OH is present, OH is present, O is present, O is present, CONH2. See here, this OH, O, OHO, all things are present. The only difference in chlomo and chlor tetracycline is in chloro tetracycline, because it is a natural, so it is having CONH2, but here this CO group is there, but this hydrogen of this NH2 group is replaced by CH2OH. So, this is a semi-synthetic derivative, means what is this? This chlomocycline is a semi-synthetic derivative of what? Chlor tetracycline. We all know that chlor tetracycline is a natural tetracycline. So, what is chlomo tetracycline? It is a semi-synthetic derivative, and when we do this type of changes by substitution of one hydrogen of NH2 with CH2OH, what we attain is, see here, what we attain is increased blood level and have greater stability than parent chlor tetracycline. Okay. Because in SAR of any molecule we have to compare the two substitutions, ki what substitution is giving better drug, better means optimized drug, right. Next, dimethyl amino group at 4th position, we have seen 1, 2, 3rd, we have seen the things. At 4th position, dimethyl amino group is essential for maintaining complete in vitro and in vivo activity, and without it zwitterions are not formed, whose formation is very essential for their distribution within the body. So, we have seen that NCH3 whole twice is also very essential, and we have also seen in the structure of all tetracycline that all are having this thing. Okay. Now, 5th position does not appear to be particularly crucial. Why? It is obvious, these are substitution. If we do not substitute this position, so it is not essential. So, the activity will not be reduced. Okay. Hydroxy group at C6, here is 4, 5, this is 6, 1, 2, 3, 4, 5, 6. Hydroxy group at C6 make molecule unstable to both acids and bases. That is why elimination of 6 OH group produces tetracycline, which are more lipophilic and are more stable to acids. You can see here that we have replaced this OH group with CH3 at the 6th position. Okay. Methacycline has an excellent antibacterial activity and is highly stable. At 7th position is what? Again we are starting from here. One, 2, 3, 4, 5, 6, 7. This is 7th position. At 7th position with dimethyl amino group, see here, minocycline is having 1 mole dimethyl amino group. 1 dimethyl amino group at 4th position is essential. At 4th position it is essential, but when we attach 1 dimethyl amino group also at 7th position, then what happens? Ki the activity is more. And what is the example of this substitution? Minocycline. Okay. So, you can see here dimethyl amino group at 4th position, dimethyl amino group at 7th position. Okay. Now, we have seen so many points, and in all the points we have seen what you have seen, just wait a minute. Okay, if we consider the general structure, what we have seen, this ketoenol tautomerism, first point, ketoenol tautomerism is necessary. Then at the second point we have seen carbonyl group is necessary, can substitute NH2, right. Then we have seen dimethyl amino group is necessary. Okay. Then we have seen that this R1 is not necessary, R2, R3, R4 can be substituted. We have seen that if in place of R4 we attach NCH3 whole twice, then the activity will be increased. So, this is the whole SAR which we have seen. Now, coming to the main point, I have told you earlier also, कि this is the general structure of any tetracycline. What we have seen, lower peripheral region is non-modifiable region where alternate double bond O, OH are present, they cannot be modified. But modified region is what? R1, R2, R3, R4. The upper peripheral region is modifiable region, right. This is the main point which I want to show by this diagram. Ki the lower portion in which there is an alternate ketonic and alcoholic group, they are non-modifiable region, but substitution can only be done in the upper peripheral modifiable region. What are those regions? R1, R2, R3. You can see here also shaded, the shaded portion is this non-modifiable region. It contact site with 30S ribosomal RNA. Bhai, you are seeing कि by doing different substitution we are changing its bioavailability, we are changing its activity, but what are the main things which is essential for the activity? These are the things, the lower portion things, alternate O, OH, ketoinol, because they are used for, they binds with 30S ribosomal subunit. Okay. Then the green arc, possible substitution can be done. Then fourth R amino group essential for anti, I have told you na ki dimethyl amino group is essential. Then radical oxygen species can be formed with this CONH2 groups. FDA approved modification. Now you have seen, you are seeing in this slide that 4 rings A, B, C, D are there, but another ring E is also there. So this E, substitution by this whole E ring is FDA approved modification which is given in the 2005. Okay. I think you understood this thing. Then again you can see here upper peripheral modification region and the lower peripheral non-modification region. See, now coming to our conclusion, in the SAR study of tetracycline, what points you think are important? The things are that ketoinol tautomerism is there, CONH2 group is there, alternate OH-O are there. These things are essential. Why they are essential? Because they are used for binding, they used to bind with the 30S ribosomal subunit. We have seen in the mechanism of action of tetracycline ki it inhibits protein synthesis, and how it is inhibiting this protein synthesis? Because it is binding with the 30S ribosomal subunit. Getting my point? It is inhibiting the protein synthesis because it is binding with the ribosomal 30S subunit. And now in the structure of tetracycline, what are the different things which are binding with 30S ribosomal subunit? These are the things, ki ketoinol, CONH2, these all are important, and substitution can only be done in the upper peripheral modification region. The things are not such ki if you means rotate this structure clockwise, the upper region becomes lower and lower becomes upper. So you say no, now it becomes lower, so it will not be allowed to modify. No, the modifiable region is where this dimethyl amino group. You have to see the plane, ki the plane should be same, ki if NCH3 whole twice is in the upper portion, then all the things can be modified here. But if it is in the lower, if we rotate this anti-clockwise, if it comes in the lower region, then they can be modified, right. You should you should keep this thing in your mind. Don't confuse by only writing this thing or by remembering this thing ki upper peripheral and lower peripheral. Getting? Okay. So this is all about the SAR of tetracycline. Now are the adverse effect: headache, blurred vision, skin rashes. One adverse effect I have told you, it shows chelation with some metal atoms. So it should not be given with milk any time, because if you are using milk along with this drug, then there is a chance that it will not show any action because it will form a chelate. Adverse effects are headache, blurred vision, seeing double, loss of vision, skin rashes, swelling of the face, throat, tongue, lips and eyes, difficulty in breathing or swallowing, and joint stiffness or swelling. These are the adverse effects which are observed in almost all the patients who are taking the tetracycline, right. Uses: it is used to treat infection which are caused by bacteria. Here we are only discussing about the tetracycline. Bacteria including pneumonia and other respiratory tract infection. There are certain infection of use, they can be used for certain infection of skin, eye, lymphatic, intestinal, genital and urinary system, and also some infection that are spread by ticks, lice, mites and infected animals. It can also be cured with the help of this tetracycline. I think it is okay. Okay. Now, moving towards the oxytetracycline. I have told you that tetracycline is a natural, chlortetracycline is also a natural, and we have seen in the tetracycline that it is a broad spectrum tetracycline antibiotic. So, oxytetracycline is a broad spectrum tetracycline antibiotic with activity against a large number of gram positive and gram negative bacteria. It is a broad spectrum. Broad spectrum means it can be used for cure of both gram positive and gram negative bacteria. It was the second of broad spectrum tetracycline group of antibiotic which is discovered. It works by interfering with the ability of bacteria to produce essential proteins. It is a fact that either you are a host or either you talk about a bacteria. The proteins are the main engine which makes the host as well as the bacteria to remain alive. But if these proteins are not synthesized, so a bacteria, either you call for a bacteria, either you talk about a host, they can't survive for a long. So, all the tetracyclines which we are talking about, they are very selective for the bacteria. That means the bacterial proteins are not synthesized, and if bacterial proteins are not synthesized, so they can't survive for a very long time. That is why they are having a broad spectrum activity. You can see here that without these proteins which are not synthesized, the bacteria cannot grow, multiply and increase in number. Structure of oxytetracycline, again I am telling you about, because if we talk about tetracycline, so the classification of tetracycline is important as well as the SAR of tetracycline for your examination point of view as well as for your knowledge. It is very important. Ki what is tetracycline? Again 4 structure A, B, C, D. Again and again I am telling you alternate keto enol system, CO NH2, NHCH3, alternate OH, O, OH. These are the important moieties, and modification where it has been done, one OH group is attached, one methyl and one hydroxy group is attached. So, this is the structure of oxytetracycline. Suppose if you want to draw the structure of tetracycline, a very tricky way of writing the structure of tetracycline is, you know that it is having a one benzene ring. Okay. This you can draw here, then put a double bond in the B. Okay. Then starting from here, put a double bond O, alternate OH, double bond O, OH. Just opposite to O is dimethyl amino group. This is keto, so at the third position enol group, and here CO NH2 group, right, and one bond also here. So, this is the main structure of a tetracycline, means a raw structure of tetracycline. Now, you can modify this by any way. So, this is the structure of oxytetracycline. Next, chlortetracycline, it is a member of class of tetracycline. Its molecular formula is C22H23Cl(N2O8), isolated from Streptomyces aureofaciens. It is the first tetracycline which is identified, discovered in 1945, right, under the supervision of scientists Lelipreda Subaru and Benjamin Minge Duggar. Then it also inhibits the same protein synthesis by binding to 30S ribosomal subunit. The structure you can see here, again the chlor tetracycline, one chlorine group, and the moieties such as one OH group is substituted here. Okay. Next, minocycline, it is a tetracycline antibiotic that fights bacteria in the body. It is used to treat many bacterial infections such as urinary tract infection, respiratory infection, skin infection, acne, chlamydia, tick, fevers, etc. The mechanism is same, it is goes and bind to 30S ribosomal subunit. Now, in its structure you can see here the presence of one more dimethyl amino group. This is again I am showing you because this is very important. Why it is very important? Because the attachment of this substitution causes its more activity, is increasing its activity. So, in this lecture we have discussed all about the SAR. Doxycycline is also there. This is also an example of tetracycline. The structure you can see here, the substitution CH3OH here are extra. So, we have discussed a lot about the structure of tetracycline and various examples in this lecture. Thank you very much.